project that we did using the software-defined radio and Raspberry Pi is to try and take data from NOAA satellites, the weather data. So for this, our setup looks something like this. So we have the Raspberry Pi, to which we connect the software-defined radio, and this is connected to the Yagi antenna, which works with the frequency that NOAA satellite works. NOAA satellite normally transmits somewhere between 143 megahertz to 148 megahertz, depending on which NOAA satellites you are using. There are a lot of NOAA satellites that can be used. The ones that we normally try to track are NOAA 17, 18 and 19. Those are active satellites, give nice data. Others are off and on. So we had to power the Raspberry Pi, for which we used a solar panel. I'm going to show that a little later on. Then we connected that to a software-defined radio, and this software-defined radio was connected to a Yagi antenna. So to power the Raspberry Pi, this is the solar panel we've been using, solar battery cell. This we got for about $50. We found it on the local market, bought it about 5 years back, and works exceptionally well for the Raspberry Pi, powers it for just over 6-7 hours. A very nice device, very handy, very easy to work with. So this is the exact solar panel that we have used out here. Now what we needed to know was the path of NOAA satellite. We need to know how to track it exactly. So for this we used a software called GNU Predict. So GNU Predict is a satellite tracking software that is open source, so most of the time freely available for you to download and start working with. So this gives us a path. So we selected the NOAA satellites, and this gave us path, something like a chart like this, which allows us to see where, let's say this is north, south, east, west. So it will show a path, something like this. So what it gives us is that we are going to start seeing the satellite from the northeast direction, and it's going to go out from the northwest direction. And it also gives us time. There are two particular data that you need to know. One is the azimuth and the other is called the elevation. Elevation is how high the satellite is going to pass through, and then azimuth is the angle, the 3D angle at which it is going to pass. So if we were to take this, so this angle in which it's going to pass would be the azimuth, while elevation will be how high on the horizon it is. Normally, right now we are in Kathmandu, which is about 22 degrees north of the equator. So for us, for this elevation to work for us, it has to be at least over the 22 degrees mark. If it's not over that, then we cannot see the satellite from Kathmandu. So we'll have to work for something, and the higher it is, most of the time the better it is, but sometimes what can happen is data can be lost. So anyway, using GNU Predict, we were able to find the path of the satellite, the time in which it was going to pass. Then we went on the roof, pointed the SDR, pointed the Yagi antenna towards the path of the NOAA satellite, and then you begin to get some sound. In the next video, we're going to show how this exact setup is done, how the data comes in GNU Predict, how the sound that comes from NOAA satellite sounds like, so that you can get a feel for it. So this is another project that we had used, and there's a lot of improvement that this can be done. This is a very quick hack to check whether this works or does not work. But this can be made into a very nice package where this can be used in rural areas or even in semi-rural areas to get regular weather data. And it can be exciting for students in times like this, when we are talking a lot about climate change, a lot of talking about how the climate pattern has changed and so on and so forth. So people who are interested in geography, people who are interested in the sciences, it'll be a very powerful tool, a very simple tool, and a very cheap tool for people to use it. The only thing is, right now there are a lot of bits and pieces that has been worked out completely differently, or they are worked one piece at a time. It would be nice if some sort of a solution is made on this, which can be used directly by the people. So you can just go and install it, start to see images. I think that crosses that learning curve, the higher learning curve that is involved with all of these devices, and suddenly allows people to see images that they never thought they could see before.